a state bit.
Yeah.
And we were wondering whether that was stateable or not, like, why do you do the this extends React component state when you don't fill it with behaviors and states?
Yeah.
I haven't seen lifecycle functions.
Yeah.
That
Yeah.
might be a good one to go through.
Well, we do that tomorrow on Wednesday, yeah.
I've seen I do use in my personal project props to pass props through a router.
Yeah.
And I had no idea what it was doing.
When you have to, when you break it out into a function,
Yeah,
the
yeah.
router, good point, because you lose it otherwise.
Yeah.
Although it's just really hard to find information on the web even, when it comes to,
Information on what?
on the internet. Like, you know, for vanilla JavaScript, there are so many sources available. But when it comes to React, it's kind of hard to find, especially if you're looking for something specific.
Sure. So anything in particular you wanted to look up, or?
Well, we were trying to get the sound to work,
Yeah.
and that was really hard.
Yeah. I think the trouble with React is that everything has changed and nothing has changed. So in the case of Scroll Magic, everything has changed. In the case of other parts of the web, nothing has changed. So once the content is on the page, you're back to where you were before. And it's knowing those boundaries. And I think going stateful with your components, extending React component opens you up to the world going on that is React, which isn't kind of familiar to us. This concept that a React component is born, state gets added to, state gets monitored, components are rendered, they're re-rendered in some cases, they're rendered twice, sometimes during a page load, and how to deal with all of that will become kind of very, very natural, I think. Particularly when we start talking about APIs. So we're going to talk about APIs generically today, but tomorrow we're gonna meld them into React components and see how that changes the way we think about our components and the way we think about the data we need for our components. Up until now, a lot of the data you've needed for components has been static, or it's been provided in some way from the front end. We're going to talk this week about how do we integrate this app, which is running in a browser on the user's machine, how do we integrate that into the wider ecosystem of things like third-party APIs, APIs you've written yourself, your own database calls, how do we bring that all together? So I think that will help solidify why we've kind of gone down this journey of introducing state and managing it. And in fact, when we get to next week and we talk about Redux, we solve a lot of the problems that are a little amorphic at the moment. They kind of feel a bit wrong, like how do I have a button over here and click it and have this component over here that's a sibling to it react to that, and how do I have these two components that are siblings talk to each other when really all we've seen is props being passed down to a component and perhaps a click event being passed back up. How do we go up and down at the same time and things like that? Conversations we have over the next couple of weeks, and you'll see that piece by piece we are putting in these foundations to building a really sophisticated web app. So a little bit of it is hanging there. We're going to expand, and a little bit of it is just try and build within the bounds we've got at the moment and see how that solidifies as we go. So I'll talk a little bit about APIs today. We've talked a bit about them. If we get time, perhaps we can see how they interact with React, but that really is a tomorrow thing, but we'll see how we go. So, what do we know about REST? We've touched it really briefly before. But let's see what else we know. I think I've got no pens at all. Hold the line, please, come on. Was it, anyone know what REST stands for? You don't have to know because it makes no difference whatsoever.
No, it's that, I just looked it up,
Yeah.
representational state transfer.
Representational state transfer. It's really all about this here though. It's about state. It's about how do we pass data? How do we create data in one place and save it in another? How do we retrieve it from where it's saved and use it in the third place? That's really all it's for. We know that there are these database things and they store our data on the disk so that when we restart our machine or our app, we can get our data back. But we also know that databases are a little bit tricky to deal with. They use these query things. They often speak on weird protocols like binary protocols over ports or across sockets. So we want to make these more interoperable between different technologies. And what I mean by interoperable is if I use Postgres for my database and you write a .NET app and they can't actually even run on the same machine, how do they talk to each other? They can't really run in the same network, say, how do they talk to each other? So what we do is we put an API in between. So an API is the generic form as a generic term, meaning two systems can talk to each other. It's a common language, it's a contract. It is an understanding of the way we will communicate. APIs, more specifically with regard to the web, tend to be called web services. The two terms are often used interchangeably, though API is a superset of web service. So web services we used to build in a number of ways. We used to use a lot of XML. We had these wonderful things called WSDLs, which were a web service definition language. And we would build SOAP web services or XML remote procedure calls. And it was a very, very involved protocol, highly speculative. You didn't really know what was going on. So we stripped all that back and said, really, we just want to pass data around. So with that, REST was born, and at the same time, we dropped XML. It stayed on for a wee while, but then we replaced that with JSON. So really, the terms we're looking at today are JSON and REST, and specifically, how do we build applications to provide these APIs? So when we're talking about data, we're generally talking about crudding in the same way that we did with our database. We would create records, we would insert them, we'd select them, we would update them, and delete them. We've just really taken that whole interaction and stepped out a layer. We're now going to put that into our web service, and we're going to take these routes that we've built before in Express, and we're going to say, Express does web pages okay, Handlebars was alright, but really what we want to do is strip away the presentation layer and just deal with the data. We know that React does presentation really well. We know that it's a very interactive environment for the user. We know it's fast. We know that it's pretty solid. So let's leave React to do what it does best, which is display data, and let's just get that data to it some other way. So we're just going to take away Handlebars and we're going to just leave the data there. So all we're going to do in our routes now is we're going to grab the data from the database and we're going to transform it into a web service and spit it down the wire. So we've talked about HTTP verbs. We've got get, post. We can talk about some other ones. Put, slash, Now, have I posted a link for you on the Rails routes? I think we did do that at some point, didn't we? Mix and Pete were here. Yeah, it's just Rails routing is a really good resource. I'll post it again so you've got it. But So get, this is our, this is read, post is create, put and patch, this is update. Delete, so just delete. So we're gonna see all of these now in our express routes. We've only really dealt with get and post, where we were creating and updating across a post, and we were reading on a get. And in fact, in a lot of cases, you delete with a post in the kind of Web 2.0 days. Now we're gonna separate them out. This put and patch is really open to interpretation. Traditionally, the way REST was set up was for updating everything. So if I had a user object, and they had a name, an age, favorite color, if I wanted to run an update, and I used the put verb, I would be expected to provide all pieces of information. So if I only wanted to update their name, I would have to look up their age and favourite colour and provide those at the same time, so I could update everything. So what's more common is to use the patch, which says I just want to update the age, so I'm only going to pass the age. So only the things I give you should be updated. Now the natural problem with that is that not filling out, not providing a property or providing it with a null value often get treated as the same thing. If you gave me nothing or you gave me a value of nothing, then I won't change that data. But if you discover that someone's favourite colour is wrong in the system, you need some way to remove it from it. So you're moving from a state of a known favourite colour to an unknown favourite colour. So that's where the patches get a little bit tricky, and that you kind of have to provide the key but not the value, and people interpret that differently. Some people strip it out because it's nil, other people always take its value. So you've got to be really careful when you're consuming APIs to look up how their updates work, because they generally vary by system to system. But in general, that's our convention, and I guess that's the key, is that REST is a convention, it's not a law. So the routes that go with these, let's keep it to users. It's the most common example. When I want to look up all of the users in a system, or I want to provide functionality to look up all the users, I might provide a route called users/users. And within the results of that, some systems on this users route will provide, say, just the ID and the name for every user in the system, and then it's up to you to look into each user that you're interested in. So they'll also provide another route which is /users ID, which we've seen before. Ditto with post. When you want to create a user, you'll post to /users. And you provide all that information, of course, except the ID, because it's the system's job to allocate an ID. Put and patch is the same as the get for a single user. Now, some systems, it's worth noting, keep this plural all the time. Other systems will make that /user/ID. It does depend, again, on the system implementer. And delete is the same deal. So that's the routes. making sense?
Are we not gonna be deciding ourselves what the address or whatever is for the routes? Is it gonna be a convention that we're gonna have to use to determine?
Yeah, so we tend to follow a convention so that consuming APIs is more efficient. Everybody has their own terminology, like some people say users, some people say people, some people have logins and people as separate things. But in general, we talk about resources. And the resources are the users, and so you have a resource which is a user, therefore you have all of these routes associated with it. You don't always provide all of them, depending on your system. If it's not possible to make changes to users, if it's just a known quantity and a known kind of resource, then they might just provide these routes. But they tend to follow these conventions reasonably strictly, so that you can, I mean, the point of an API is to give someone else access to your system. So if that's beneficial to you as a provider, either you're charging for that or you just want your users to build cool apps to use your data, then you want to make it as easy as possible. So the way you do that is you follow the conventions they're used to.
Previously, we would have gone users/ad/edit.
Yeah, and you often will still do that for an edit page. So what you've got to remember with these is that there are no forms here. The forms are being done by the front end now. So there may well be a route on the front end which is users/id/edit, and under the hood it'll post or put and patch. So we're also disconnecting those two parts of the interface, the URLs of the front end versus the URLs of the back end. So that gets a little tricky when you're thinking about it, in that we're used to typing into our URL, into our browser address window, the URL we're looking at, and seeing the hit on the server at that route. And when we click a link, we see a change and we see the route change. Because we've disconnected those two now, React is handling all those routes in the front end, and then Express is sitting on these RESTful routes, they're called. So debugging gets a little bit more of a head job, because you've got to think, well, when it's at the wrong URL in the address bar, it's because something's wrong with React. But when I hit go and it says I can't contact the API, chances are it's a problem with your API client or server. Cool, so just to quickly touch on JSON, we've looked at JSON before. Now this here that I've written is in fact just a JavaScript object. You can tell that because I've got very few quotes. So when we move to JSON, this is JS. They're deceptively similar, but both very strict. So you've got to get them both right. So the JSON representation of this would be user in quotes, colon, opening up, OD, in quotes. So JSON as I guess it's a markup language, it's an encoding language, it's a marshalling language. It has kind of only really two data types, three data types maybe, and two major data structures. It has a hash or an object and an array. Those are the two data types you've got to deal with, the data structures you've got to deal with. The data types you've got are integers, booleans, and strings. I don't think there's any others you can do. So you've got to think about how to represent your complex objects in this way. That ID thing, name. You get the idea anyway. So really you just got to quote all of your keys and quote your values when they're strings, and use booleans and integers are the only things that don't need to be quoted. The other thing that trips a lot of people up is JavaScript on this last item here, the last item in a list. JavaScript will allow you to have a comma on the end, JSON won't. It's a very common parsing error. I almost always have commas on everything because it makes your git commits a little cleaner. When you add another line, it shows you've added another line rather than showing that you've added another line, added a comma on that line and mixed it up. So I get a bit pedantic about that, but it doesn't work in JSON, so you've got to make sure you don't have a comma on the last item. And that's about all there is to it. In terms of Express, we have a new middleware that we'll introduce, which helps you encode with JSON. So you pass it a JavaScript object, it'll turn it into JSON. Makes it way easier. When you've got to deal with strings yourself, it gets a bit painful.
So why would you use JSON over JavaScript, like, apart from you package JSON on it?
So the idea is JSON turns JavaScript objects into a basic string. It's a really good question. So because HTTP is going to be our mode of communication, it only knows about strings. So really it's a way of turning these complex JavaScript objects that exist in memory into something we can print on an HTTP character string. It's just a way that we can communicate the data. Cool. So, with that said,
So all APIs communicating on HTTP strings?
all RESTful APIs are, yeah.
Okay.
Yeah, so you can have APIs that work in other ways, but we don't use them. They're pretty old school now.
Okay.
You only really do that sort of thing when you've got something complex to do. If you are passing images around or you need a more real-time interaction, you might switch to some other protocol, like WebSocket style, but it still runs over HTTP though, but it's just a bit different.
So is there an API for like SQLite or something? that we're gonna be-
No, so we write that bit.
We're gonna write that, oh yeah.
So your database calls stay the same. We just put an API between React and those database calls.
Ah. And so we can share that API with other people if we want to be able to access that database.
Exactly. Yeah.
So we're writing our own APIs, that's cool.
Right, so, yeah.
If APIs are all written with similar convention, could you guess somebody's API?
Yeah, totally.
Oh,
I
really?
end up doing that most of the time.
Ah. And what if they didn't want to share data with you? Too bad.
Then they put authentication over the top.
Ah.
Easy. So today we will look at Charts Weblog again, but this time with an API. But what's that? Yeah, sure. Okay, so this project is another boilerplate with APIs set up. It's not set up as you're used to seeing it, so by all means rearrange it if that's helpful. The server.js is just kind of sitting out here, but we can move that around soon if you'd prefer to see how that's done. It's very straightforward. So the one thing to look for here is this bit, middleware server.use express.json. So that says I'm likely to get requests coming in JSON format, or in, so this is particularly the posts, puts and the patches, where the body of the request will be in JSON encoding rather than in the URL form encoding that we're used to seeing. So that's all gone now. We won't use that again. It's all been replaced with Express JSON. So that's the one piece that we're changing. The other piece, so one of two pieces. The other piece that was changing is this bit here. So where before we did request.send, which that's actually wrong, that should be JSON. Now we're using response.send, sorry. We'll use, rather than response.render for handlebars or for templating, we're using response.json. So what we're saying is I'm going to pass a JavaScript object, and I want you to turn that, I want Express to turn that into a string JSON representation of that object. So put in all the quotes and all that sort of thing. So we don't have to write that by hand at this point. Express will handle that for us. So the routes look very similar to what they did before. The only change is that res.render or res.send or res.send file is now res.json. So then I can show you here, if I fire up this app, I've got no root route. If I go /users, I get just a whole lot of JSON. Now, this is rendered pretty. I've got a browser extension called JSON Formatter. If I turn that off, you'll see it's just a JSON object, no line breaks, but all the pieces are the same. So there's one user there. But I recommend having a JSON formatter of some sort in your browser. It just makes it a little bit easier to deal with. You can fold up the code and things like that so you can see what you're looking at. Makes things helpful. The other app I want to show you when you're dealing with APIs is, because what we've done now is we've got React over here. It's going to be calling these APIs eventually. But what we type into the address window of the browser is going to be different from what we need to call on the back end. So we're going to need some way of checking which part is broken when inevitably we load a page and it doesn't do what we expect. We want a way of checking that the API is behaving as it should, therefore the problem's in React, or the problem's not in React, the problem's in the API, so we can fix the right piece. So we introduced a tool called Postman, which is for posting to your server as well. Yeah, it's unfortunate. It's the best tool. I mean, I tend to use the command line. There are lots of other things. It's a free app. This is an application that allows you to build requests to your API and get updates to the app, but also it kind of interact with your API in a way that's a little more helpful. So I put in here the URL I want to go to, and I can select all of the different verbs. Now this app has a wider scope than we use it for. A lot of these other verbs you can see here are to do with a protocol called CalDAV, which is a way of interacting with calendars. It's also an old school API, but so we really only use these top ones. I'll select get at this point and hit send, and it'll do the JSON formatting for me. It also gives you the status codes, any cookies that got sent, any headers that came back in the response. So it's It's a nice little tool for interacting with your API. So because your browser, you can do the GET request no trouble, but when you want to do a post, it gets a bit more tricky with the browser. So that's when you need something like Postman. You can actually do it on the command line, as I've shown you before with curl. It's HTTP. So that comes back in the same way. So there's, with curl, you can use the -X to send post, or any other. After the X there, you can use any verb you like. You've then also got to provide a body to the message, which you can do with another switch. It escapes me right now. I tend to put it in a file actually, so I can show you that if you're interested. But I would stick to using this here. It keeps a history of everything you've done, so as you're testing, you can go back and just click one you've already sent, change that to a post, send. So now I can choose from these, or pre-populate the form. It's a handy little tool, that one. Also, the challenge today, you're going to rewrite the server side of Charlotte's Weblog to serve up things with an API. You can interact with it with Postman and just have it play. And just get a real feel for the way these verbs change based on the action you want. The way you specify the params is the same as we've done before. You can use the same get and post string matching for the parameters. Yeah, and then there's another exercise you can do after it, which gives you almost no structure, but a bunch of user stories for building an API. So yes, you can play with that too. Any questions on all that?
Are we staying away from React for this exercise?
This just today we will.
Yeah.
I just want you to focus on the mechanics of the API. Tomorrow we're going to slap React in front of it. But that's another head job in itself, so we just want to make sure you kind of get a feel for which parts of the API and which parts of the React lifecycle interactions. Any questions? This is kind of one of those ones you really have to play with to get it, yeah.
Just one more around how the API connects to what we've learned so far. I know you touched on it earlier.
Yeah.
Just
Let me
to
draw you the application, then change it. Let's stop this. When we first arrived, we had the web browser here, the person, a little URL bar, HTTP, blah, blah, blah. And it would send a request, and the first bit of call was Express with its routes. And when we got full stack, that would involve going to the database. So this would be, I've forgotten its name, Connects plus SQLite. So you'd ask for your data, get one more. That seems a long time ago, doesn't it?
Yeah.
Then the data would come back, and that's just It's just a row from a table, so it's nothing particularly interesting that we can send to the user. So then we would call in the help of our template with handlebars. So we'd say render that, and it would come back with a string.